All right, another log problem. If f of x is negative log a of x minus 3, where a is between 0 and 1, find the horizontal asymptote of h of x if h of x is 2 times inverse of parentheses x plus a cubed. So h of x is given to us not in terms of f exactly, not exactly in terms of f inverse of x, but in terms of f inverse of x plus a. So let's start with finding inverse of x. Then we can work our way to the next steps. So we start by, so f of x here, that's the same thing as y, right? So we're going to replace f of x by y. So y is equal to the negative log of a, log base a, excuse me, of x minus 3. The next step in finding the inverse is you're going to want to swap x and y. So where x is, you put y. Where y is, you put x. That gives us x equal negative log base a of y minus 3. All right. Good. And from there, now we gotta solve for y. So we need to find a way to isolate the y. And that once we were able to isolate y, that answer will give us inverse of x, inverse of f. So to do that, I'm gonna rewrite this starting with the log. So we have negative log base a of y minus 3 equals x. And now we want to convert this equation, this logarithmic equation, into an exponential equation. But to do that, we gotta remove the negative sign in front of the log. So we can simply do that by multiplying both sides by -1. And we're going to get log base a of y minus 3 equals negative x. And so the way rewriting it starting with the log now helps us convert it in a visually easier way. And why do I say that? So to convert from log to exponential, you always start with the base. So the base, you raise it to whatever is across the equal sign, and that will be equal to whatever you're taking the log of. You're taking the log of y minus 3. So let's put that together. So again, you start from the base, a to the power of negative x, and that equals y minus 3. And that works every time you want to convert log to exponential. You just want to make sure there's no negative sign in front of the log. And then if you write the log first, that hopefully helps you visualize the arrows, right? They go counterclockwise. So base to whatever is on the equal sign, and then that pair of base to exponent is equal to whatever you're taking the log of. And then, as you can see here, it's pretty straightforward to isolate y. We add 3 on both sides. So y, that is inverse of x, and it's a to the minus x plus 3. And then the 3 is not exponent, it's just in addition to the a minus x. So it's not the final answer, but I'm just going to put it in the box just for us to remember. Now, h of x, let's keep in mind, h of x is 2 times the inverse of x plus a. So let's start with finding f inverse of x plus a. I know that trips a lot of people sometimes. So when you have an x plus or minus something in the parentheses. What do we do with that? So one way to look at it, to think about it, is whatever is in the parentheses now, x plus a, is going to replace any previous mention of x. So anywhere you add x in the original inverse function, you're going to replace it by whatever is in your parentheses. So in this case, you're going to replace x anywhere you see x. So here, we used to have x in the original inverse function, right? We're going to replace it by x plus a. And then there's still the plus 3 on the outside. The 3 plus 3 is unchanged because the 3 was not tethered to any x. So it's just plus 3. And if you want, you can, you can just expand, distribute the negative sign at the exponent level. So minus x minus a plus 3. And then to find h of x, it's going to be 2 times this whole thing. So h of x, let me use a different color to limit confusion. H of x is 2 times the answer we just found. So 2 times that. So 2 times a minus x minus a plus 3. And then plus a cubed. That's what h of x is. We're told h of x is. All right. That's that. And if we want, okay, actually, let's expand. So it's going to be 2 times a to the power of minus x minus a plus 2 times 3, which is 6, and then plus the a cubed that was standing outside the parentheses. So again, that is h of x. All right. And I want to highlight, so here you have, in that answer, you have, in that answer, you have this portion, which is the exponential portion, because it's a base raised to the power of a variable, in this case, x. So this is the exponential, the portion that I circled in pink is the exponential component of h of x. And the portion right here is the constant, because it's a, remember, a is a constant between 0 and 1. 6 plus a cubed is the constant. And the reason why I'm highlighting those two is it will have, it really, the answer for the horizontal asymptote is the constant. But let me do a quick look back. If you remember your exponential functions, right, e to the x, right, it's e, which is a constant, 2.718, whatever, raised to the power of x. And how does it, what does it look like? It looks something like this, right? Really, like it starts almost like it's taking off from the x-axis, y equals 0, right? And then it cuts out, and then it cuts the y-axis at 1, and then goes for to infinity and beyond, right? It just does that. Well, think of it this way: what is the constant of e to the x? What is the constant being added or subtracted? So it's really e to the x plus 0. And why do I put the 0 here? Because hopefully it helps you visualize that the portion that is being, the constant that is being added to the exponential, that constant will always, again, always represent the horizontal asymptote of the exponential equation, or of the exponential function. So in this case, e to the x, y equals 0 is the horizontal asymptote. For if we do e to the x minus 2, what is the constant being added or subtracted to the exponential? Negative 2. So y equals negative 2 will be the horizontal asymptote to e to the x minus 2. So let's do a quick graphing portion. So let's graph it here. So if we start with e to the x, right? E to the x. So you see, again, what's the asymptote? Y equals 0. Let's do the other example that I mentioned, e to the x minus 2. Look at that, right? Instead of starting at the x-axis, it starts 2 steps down. And you can also see that between the two equations, there's like a transformation, there's a shift by 2 units. So you want to remember, when you have an exponential equation, the constant that is being added or subtracted to the exponential component will always stand for the horizontal asymptote. So now let's go back to our equation, h of x. You see how I broke it down into the pink portion, which is the exponential portion, right? The base raised to the power of the variable x. And then the portion in brown, the 6 plus a cubed, that is the constant. Well, that constant is, so y equal, we'll get there. Come on. Y equals 6 plus a cubed is the answer. It's the horizontal asymptote of h of x. Now, it may be too much of a concept, so let's use an example. Remember, a was between 0 and 1, so let's use a equals 0.5. 1/2, right? 0.5. If a equals 0.5, that means for the sake of our example, f of x, where are we at? F of x was negative log base 0.5 of x minus 3. And we're going to do it in math way. And if our math is, the work we did was correct, it was correct, but we will double check. We should get an inverse function of f negative 1 of x should be 0.5 raised to the power of minus x, and then plus 3. So then h of x should be 2 times 0.5 to the power of negative x minus 0.5, and then plus 3, and then plus a cubed, so 0.5 cubed, which should be 0.125. And if our math is correct, the horizontal asymptote better be y equals 6 plus 0.5 cubed, or 6.125. So what we're going to do right now on Mathway, we're going to plug it in, plug in f of x and ask it, hey, Mathway, tell us what's the inverse. So let's do that now. So negative log base 0.5 of x minus 3. All right, Mathway, what's the inverse? Check this out. 0.5 to the negative x plus 3. What did we find? 0.5 to the negative x plus 3. All right, so now what we're going to do is we're going to enter h of x and ask for the asymptote. So it was 2 times 0.5 to the power of negative x, negative 0.5, and then plus 3, and then plus a cubed, plus 0.5 cubed. Let's see. Yes. So we're going to type that and ask, find the asymptotes. And check this out. Y equals 6.125. Y equals 6.125. So there you have it. This last portion, if you understood the concept, this portion you didn't need that you didn't need anything I did after that. It was just to help anybody else visualize why we were correct by plugging in a number. That's it. Thank you so much.